Ica is one of the most arid regions in the world. In it, we Peruvians have managed to develop large agricultural projects. We produce grapes, avocados, and blueberries, among others. To tame the desert, we have had to learn to manage our water in the most efficient way possible. It has been very difficult for farmers to learn about the danger of water scarcity and to consider it a finite resource. The main problem lies in the fact that although we have internalized the problem, the authorities responsible for its control and management, as well as the population itself, have not yet done so. This is the reason why most of the riverbeds, ditches, lakes, and our sea are highly polluted. In recent years, the agro-industry that has been exploiting the valley's groundwater aquifer for decades has started to implement combined surface and groundwater use systems, but these programs are limited by the high contamination of surface water. According to the Peruvian Ministry of Housing, 56% of wastewater is discharged untreated into natural water courses. As for the remaining 44%, we have found state treatment plants where the water has left the plant more polluted than it entered.
If we talk about the population, living in a country where education and health care are very poor and corruption has impoverished us for decades, wastewater management is not a priority in the popular consciousness.
Two problems are evident here. Firstly, the lack of wastewater treatment due to its high cost and low political importance in our region. And secondly, the loss of large quantities of fresh water to the sea that could have been used to reduce the consumption of groundwater if they were not so polluted.
What you are seeing now is Tinguiña's wastewater treatment plant, and as you can notice, it's not in operation. It was built in 2017 and designed to treat the wastewater of settlers from different villages of the area. The cost of implementation was $2.5 million and fell into disrepair after only a few months of working. The reason they stopped using it was that they didn't calculate the operating cost, opting to divert untreated water and discharge it into the river. However, harmful as it may be, the lack of awareness of the environmental damage by the population and the authorities has made this general methodology in our area for wastewater management. As farmers, this has complicated the use of surface water for export and puts our population in continuous danger by using this water to irrigate products of national consumption such as potatoes or beans. In 2016, our company acquired several fields near the wastewater treatment plant of San Jose de los Molinos district. This consisted of 4 pools where the wastewater arrived and circulated from one pool to the other and finally poured into the fields without any time of purification in the process. The contamination made it impossible for us to use these lands for environmental conscious agriculture and to produce products that were safe for the health of our workers and customers. We decided to take control of this plant and transform it into a format that treats water in an environmentally friendly way. With this system, we were able to recover the more than 30 hectares of the area that were lost and used as illegal dump. We could not have achieved this without the support of the mayor of the municipality, who was extremely open to consummate this win-win format. Over the past 4 years, we have managed to develop a high-quality mandarin crop, which is not threatened by pollutants from sewage discharge. The treatment plant we have implemented uses a dynamic aerobic biofilter system, BIDA for short. This plant has generated great interest in the region because of its unique handling system, its low operating costs, its environmental friendliness, and above all, the fact that it has been developed by a private company at its own risk and cost. Our aim is that this type of initiative will be replicated by other agricultural companies and in this way recover the quality of the water coming down from the mountains and be able to reduce the consumption of groundwater to alleviate our aquifer.
The way we treat the water is as follows. The raw water enters the first pool where the sewage sludge is decanted. Once every 2 years, this sludge is removed by a company specialized in the treatment of this waste. On the opposite side of the pool, there is a pumping unit that sucks the water from the surface. The pump lifts it up to fall through this parabolic filter. The water falls through the slits and other foreign materials such as wood or plastic are retained in the lower basket. Any excess water that might fall into the basket is returned to the initial pool so as not to be lost. The process continues with the water falling by gravity into this Australian tank, where 4 hydrojets are used to recirculate and mix the water in the tank to homogenize it. The aim of this is to avoid concentration of oil or chemicals that may affect the balance of the organisms of the following stages. After this, the water that has not yet received any treatment is sprayed by sprinklers into these 2 large containers that are filled with wood chips from our pruning. This wood absorbs the water and retains the organic matter it may contain. This organic matter and the wood itself is treated by a large population of earthworms that we inoculate into the surface layers of the chips. After 2 years, the wood has already reached a state similar to vermicompost, which makes it a high-quality natural fertilizer. It should be taken into account that in agriculture, pruning residues are so abundant that it is a common practice to burn them, which is also a major source of air pollution. Considering our company alone, we produce more than 2.5 million kilos of this wood per year, on 350 hectares, which could be composted with this system. Back to the water treatment, this is finally pumped through an ultraviolet system that kills viruses and bacteria that remain in the water. Along the years, we carry out various analyses, both at the entrance of the water to the first pool, at the exit of the wood chips containers, and at the end of the treatment after UV. As you see, the water at the entrance of the pool are typical of urban areas without industry. They are relatively clean water. After passing the chip filter, the drastic decrease in the chemical and biological oxygen demand is evident, while the decrease in microbiological parameters is already significant.
Here you can see the results from the first to the last analysis, and in the third column, the legal parameters that we must comply with. You may be wondering, so what do these people want from us? According to the Global GAP, the use of sewage sludge is prohibited on certified farms, and we agree with this condition and do not ask for it to be changed. What we are asking for is the recognition that the product we want to produce is not a sewage sludge. Here we can see up close how the wood shavings have been decomposed by the work of the earthworms as mentioned above and has become vermicompost. This material is essentially used in new plantations to mix it with the soil where a new tree is to be planted because it contains water-soluble nutrients and is an excellent soil conditioner. The microbiological load of this product is composed of Bacillus bacteria and Fusarium and Penicillium fungi. As far as bacillus are concerned, they are thermophilic type and are responsible for initiating the thermal sterilization process in composting. We are looking to mix the inedible fruit with the wood chips in order to compost them together, as our pruning production is larger than what we can use to treat the water. To achieve this, we rely on the Farm Composting Handbook published by the Natural Resource Agriculture and Engineer Service, which is commonly used by FAO to identify the best ways to compost.
Out of the different composting methods that exist for the materials we want to work with, we have identified the forced aeration pile composting system as the most suitable to obtain a homogeneous and innocuous product. In this format, the crushed fruit mixed with the wood chip make up the body of the compost pile, which receive the oxygen necessary for the process through pipes that intermittently push air into the mixture. Finally, the structure is completed by placing a layer of compost on the outside of the pile to inoculate the bacteria necessary to trigger the decomposition and composting process. In our case, we will use the vermicompost we produced. Once the process begins, the temperature of the pile rises due to the action of the thermophilic bacteria in the humus. After the second or third day, the temperature exceeds 60 degrees Celsius, which is maintained for the next 15 days. At this stage, the final product is made safe by killing any viruses and harmful bacteria. With this process, we have converted what was a useless waste that was burned, polluting the air, into a high-value fertilizer widely used in agriculture. Installing a treatment plant in our area is not profitable under our reality, but using this model could encourage other companies to implement this method of water treatment and composting, because it creates a source of income and cost reduction for the farmer. This could drastically reduce both air and water pollution in our region, but this will not be possible if Global Gap does not differentiate it from what would be sewage sludge. Our project is just starting, and we would like to count on you to guide us as far as possible so that this format can be replicated wherever it can help to ensure a sustainable future.
Thank you for your time.